Packet forwarding process. In this video, I'm going to talk about the packet forwarding process. What is happening when we are sending a packet from one source to one destination? What are the content of the tables that we need them, and so on. Because of that, in this video, we are talking about the process of the packet forwarding, and we are trying to understand everything necessary for troubleshooting the packet forwarding process. This is so important because in many cases, in many courses of the troubleshooting, the first thing that you need is understanding, is informing about the packet forwarding process. When you know about the packet forwarding process from the source to destination, you can easily find the reason and the source of the problems in one network, and easily you can solve them. And also, after that, you can use this knowledge for troubleshooting of the other features of the network. Because of that, this is an important video related to the packet forwarding process and also troubleshooting. Okay, let me to start the configuration of this scenario. After that, step by step, we can talk about the other details. Here we have two LAN. This is the first LAN, as you can see, R1 connected to one LAN with one computer, and also R2 connected with another LAN with another one computer. Okay, here we are using the 192.168.10/24 as the IP address, and here we are using the 192.168.20/24 as the range of IPv4 address. Between the router 1 and router 2, I am using, as you can see, one serial link. Here you can use HDLC or PPP. Let me to use the HDLC because in the CCNA we have learned about the HDLC, and HDLC is the default protocol on the serial interface. First, we need to configure the scenario. Starting from the router 1, the configuration is so easy. enconfd interface, for example, serial 10. Okay, and then IP address of this interface is the 10.0.0.1.255.255.255.252, and then no shutdown. Because here we have a point-to-point links, it's better to use the /30 as the range of IPv4 address. And also about the interface ETH00, let me to configure the IP address 192.168.1.255.255.255.0, and then no shutdown. Okay, after that, let me to configure the router 2. This is the router 2, again confd interface serial 10, IP address 10.0.0.2.255.255.255.252, and then no shutdown. After that, interface fast ethernet 0 ETH00. Okay, here we should configure the IP address with the 192.168.2.1.255.255.255.0, and then no shutdown. And after that, if you want to have connectivity between these two networks, you know that you need to enable one method of the routing. Because of that, and now you know that router 1 doesn't know anything about the 192.168.2.0. Let me to show you. The routing table of router 1 can be seen with the show IP route. In show IP route, as you can see, we have only two connected networks, the 192.168.10/24 and also the 10.0.0.0/13. Okay, here. And after that, in the router 2, if you check the show IP route, you can see that we have two connected networks, 10.0.0.0/30 over the serial 10 and 192.168.2.0/24 over the ETH00. You can configure one method of routing, for example, static routing or dynamic routing. The method of routing here is not important for us. Okay, we can use one of the routing protocols or a static route. Maybe a static route is easier. Let me to configure one static route in the router 1. Here I'm going to configure this static route, IP route 192.168.2.0.255.255.255.0. After that, the next hop is the 10.0.0.2. Okay, if you want, you can configure both next hop and outgoing interface serial 10, then 10.0.0.2. This is the static route of the router 1. If you want, you can check it with the show show IP route static. Okay, here we have one static route to 192.168.20/24. the outgoing interface is serial 10 and the next hop is 10.0.0.2. This means that if a packet received to the destination of 192.168.20, you should forward it over the serial 10 and with the next hop of the 10.0.0.2. So easy. Also in the router 2, we can configure again the hostname R2, again another static route, or for example IP route 192.168.10.255.255.255.0. then outgoing interface is serial 10 and the next hop is 10.0.0.1. that's it. Then show IP route static can show us that we have now one static route. The network is 192.168.10/24. After that, the outgoing interface is serial 10 and the next hop is 10.0.0.1. That's it. After that, finally, we need to assign the IPv4 address to the PC1 and to the PC2, and then we can check the connectivity between these two PCs, and after that, we can talk about what is happening. This is the PC1 desktop. Okay, let me to assign the IP address. You can use DHCP to assign the IP address, and also you can assign the IP address manually. In the PC1, this is the PC1 network interface card. I am going to assign the IP address of 192.168.110 manually. Okay. And after that, you know that here we should assign the default gateway IP address. 192.168.1.1 is the address of the default gateway or the router 1. That's it. This is the configuration of the PC1. Let me to save it. And after that, here in the, for example, PC2, again, I'm going to assign the IP address to the interface of PC2. The IP address of the PC2 is 192.168.210/24, and after that the gateway address is 192.168.2.1. This is the 192.168.2.1. let me to save it. Okay, and then close. Okay, now we can check the connectivity, but before sending the traffic between these two computers, it's a good practice, okay, to using the Wireshark for capturing the links because I'm going to show you what is happening after the first ping or first sending traffic. Okay, let me to capture first ETH00. This is the ETH00 capture ETH00. Okay, we will analyze it after sending the packet. This is the ETH00, and then let me to capture also the serial 10 here. As you can see, we cannot capture this link. It is not important, but let me to capture the for example the ETH00 of the router 2 capture, and then ETH00. Maybe in some versions of the emulator you can use to, such as the GNS3 or some other emulators you can capture here. Okay, it's not important. Only we are capturing the link between the PC1 and R1 and the link between PC2 and R2. Then let me first sending a traffic from the PC1 to PC2. We are trying to verifying the accessibility of PC2 in PC1. Ping 192.168.2.10. Okay, as you can see, we have connectivity, and now here we have to capture. Let me to stop the first capture and also the second capture, and after that we can start our analyzing over the packet forwarding process, what is happened, and what is the for example detail of the packet forwarding from one device to another device. Here we have one notepad file for better analyzing all of the process. You know that first we need to gathering some information. For example, about the PC1, we know that the IP address of the PC1, okay, is the 192.168.110/24. And also we know that the default gateway of this PC configured with the 192.168.1.1. And after that, we know that the MAC address of this PC1 is, let me to find the MAC address here in the PC1. This is the PC1. You can use ipconfig/all, okay, for finding the MAC address of the for example PC1 network interface card. This is here, as you can see, we have multiple network interface card, but here we have one Ethernet adapter local area connection, and IP address was assigned to this interface. Because of that, this is the MAC address of this interface. Let me to write here, the MAC address is 5,000, okay, in dotted triplet notation, for example, 5,000. After that, 0001 dot, then 0000 quad 0. This is the information that now we have about